can't say that. We're good? All right, cool. So thanks for inviting me, and thanks everybody for showing up. I know that database scalability is probably the most exciting thing on the planet, and so I'm glad you guys are recovering from your post-lunch coma here. So, I really hate slide decks where people just run through and talk about the features of whatever product they're selling. And granted, I'm probably going to do a little bit of that, so I'm guilty. But I'd rather just start out telling a story about my life, in that I've been writing code since I was 8 years old, and professionally for the last 10 years. And I've always concentrated on database infrastructure. My first job out of college, in fact, I worked at Microsoft on SQL Server. And something has always really irked me, and that is that when something goes wrong, it's the database guys who get blamed. When you can't add a new feature to your product, it's the database that gets in trouble. When you need to spend hundreds of dollars on consultants to keep things alive, hundreds of dollars an hour, it's the database. And every application I've developed, when you start to become successful or when you start to grow, the database breaks. And it's really sort of horrible to think that there's so much we could do in this world if the frickin' database would just work. So that's what I set out to do 2 years ago and why I started drawing to scale. I wanted to build a database that stays fast no matter how much data you put in it. Whether it's structured or unstructured, whether you run it in the cloud or on premises, it just works. And that's what Spire is. It's a database for real-time big data. And it's real-time because it's the first database that I've seen on market that's been built from the ground up to be completely distributed. There's no legacy relational database in there. It's not sharded. It's truly distributed from the ground up. And we built it because our customers kept coming to us and said, hey, guys, we have millions of power meters across the Southwest, or we have millions of cell phones in Afghanistan and Iraq, and we can't stream all that data into one place, nor can we let our customers log into this database and see their billing or track their usage, or in the case of some of our customers, we can't stream Twitter into an existing database. Everything we do just breaks at scale. And so that's why we built Spire. It's a real-time database. It's usable by developers because it supports SQL and search, but it operates at scale at use cases like this. I'm sure you guys can all think of one. And right now, when people say big data, the first thing that comes to mind is Hadoop. And Hadoop is a great foundation for big data. It can hold huge files, it can hold a lot of files, and it can process them in a few minutes to hours. But Hadoop will never be real time. Even the CTO of Yahoo said this. Hadoop is fundamentally a batch processing framework. And it's not a database. It's really hard to use. There's some tools on top of Hadoop to make batch processing easier, but people just want to stick their data somewhere and query it and have it stay fast. And that's what we did. So what are people doing without Spire? A common thing we hear a lot is, well, we use Hadoop here, and we have a data warehouse here, and we have our OLTP store here, and there's sharded Lucene over here, and the cool dude with the glasses is experimenting with Mongo over here, and it's really easy, and even the largest enterprise, to see dozens of different kinds of databases. And when you need to grow those databases, every single one has a totally different solution. You sort of have to hand roll a lot of code. You have to slice and dice your data in really bizarre ways. And you spend all this time focusing on building stuff that's not core to your business. A lot of guys are building their own database internally from scratch. And another thing we see a lot is people crunching data in Hadoop and then loading it into something like MySQL or Mongo, which is really great until that MySQL or Mongo or Couch or Oracle runs out of space. And then you're stuck again. And so there's a few things that we've spent sort of years obsessing over and developing to make Spire extremely fast and easy to use. Now, on the bottom, there is Hadoop and HBase. HBase is by far the largest deployed distributed database outside of Google. Powers 6 petabytes of data at Facebook and growing. And we've built something else. We've built a distributed index. It's the first of its kind. And what this is it's an index with a global view of the data, not just local to the nodes. Whereas pretty much every sharded database out there, if I've got 50 nodes and I want to run a simple query like that, I have to query every single node. Our database already has a global view of the data, and our algorithms are smart enough to run a query like this would probably only run on 3 servers instead of 50. So you can imagine it's a huge increase in throughput and a great decrease in latency. But beyond just SQL and full text search, you have to make data usable. And from an operations standpoint and an ETL standpoint, we're building tools. And I don't know if you can see it too well, but we want to make using big data in a database as easy as drag and drop. And like I said earlier, it works because everything is distributed. We assume any node can fail at any time. We also assume that you need to be able to add and remove nodes, mostly add at will. And that one person using the power of Chef and our management tools should be able to handle hundreds of nodes. Because as you guys know, the first people who always want to say no to a database is IT. We want to make IT's jobs easier. It's really easy to buy, too. No multi-year horrible contracts. There's just a simple monthly subscription, $500 a node. And people are using it now, everywhere from telecoms to smart grid to social media analytics. There's a lot of folks out there who just want a SQL database that scales and is really, truly distributed.
All right.
Thank you.
Great. Got to cut you off.